Hello everybody, this is Cap here, and today we are going to be talking more about vectors. So I'm going to explain what's going on down here in a second, but for now I'm going to go ahead and create a vector. And I'm going to make a vector of integers. I'm going to call it V, and we're going to tell it to start out with one element. So we're going to print out the address so that we can find it in memory. And now we'll get to this down here. So if you guys can remember from the last video, and if you haven't seen the last video, I would highly recommend you watch it if you want to know what's really going on here, because I'll probably reference it quite a bit. So if you can remember, we have a beginning pointer in our vector, we have an end pointer, and we have a capacity pointer. So this is essentially, I guess you could say, our vector, and then we have our vector data. So our beginning pointer points to the beginning of our vector data. The end pointer points to one past the last element in our vector data. And then our capacity points to one past the last, I guess you could say, element space in our vector data buffer. So basically, if you keep pushing elements onto your vector, eventually once it gets to capacity, usually it will have to move it somewhere else. So let's make a loop here. Say 6. We're just going to say pushback I. So every time it goes through this loop, it is going to push another value onto our vector. So what we're going to watch for is how many times our beginning pointer moves. Because when our beginning pointer moves, we can pretty much safely assume that our vector data has had to move, which means that all of our vector data had to be copied over to somewhere and then, freed up and all that stuff. All that good stuff. So let's step into this. Okay, now I have the address of our vector. Okay, so as with before, we want to watch these three pointers here, these three addresses. Well, actually, for now we want to watch this one, the beginning pointer address, and see how many times it changes as we go through this loop. There it changed, changed again, and again. Didn't change that time. Changed there. So that was a lot of copying and allocating and all that going on, which does take up resources. Now, it doesn't take up much resources, or many resources, considering we're only dealing with integers here. But if they were extremely large objects, this could, have a bit of a performance cost. So what can we do about it? Well, vectors provide two methods that can, essentially allow us to manage these two pointers here, our end and capacity pointers. So what we can say or do here is say that I know I'm going to be adding, quite a few elements to my vector here. So I want my capacity pointer to go all the way out to here so that it doesn't have to move my vector data quite as much. And we do that using the reserve method. So I can say v.reserve, I'm going to say 10. So what that's going to do is it's going to reserve 10 or space for 10 elements as a whole. Not 10 more elements, but 10 elements as a whole for the vector data. So let's step into this again. Right, so I'm guessing it's probably going to have to move it for our reserve here. Yep, there we go. So now we can find our data in memory. 88. Alright, so since we told it that we want one element to start out with, it has already initialized one integer here and set it to 0. And also, since we said to reserve for 10 more 10 elements, our buffer should cover quite a bit here. It should have reserved quite a bit of space. That way, we don't have to move any of it, because we know we're going to be adding quite a bit to it here. So let's step through it here. There you go. And as you can see, the only thing moving up there is our end pointer. And there you go. See, we only had to move our vector data once when we reserved space for it. And so that's, basically what our reserve method does. So let's talk about the resize method. Pause that. So our resize method basically allows us to do, the same thing with our end pointer. Say, okay, so I want the end pointer to point to, here. Because I know for sure I'm going to be using these spaces, and, I want them to be already initialized and whatnot. So let's change this to resize 10. Do that. And instead of pushback here, because remember, pushback pushes something back onto the end of our vector. But we don't want to do that because we haven't extended the end of our vector buffer here. We have, but we've extended the end of our vector data, which means that if we did a pushback, it would start putting our elements here and keep going there. But we want it to start, here and put them like that. So instead, I'm going to say vi, and we'll just set the value equal to I. So once again, let's step into this. Okay. Okay, so you'll notice something quite a bit different here. Now we have all of these here initialized to 0. So essentially these are part of our vector data. So I guess you could think of it as the resize altering our actual vector data, like extending our vector data, and then the reserve extending our vector buffer. So let's step through here. And as you can see, it's just going to go through and change them. And we won't have to move the data until there. Well, that was the end of the program, so of course it released it all. So that's what the reserve and resize methods do. They allow you to kind of manage your vector data a little more efficiently. So I don't think in the last video I covered Popback. So let's take a look at that here. So actually, I'm going to keep that. Going to have it print out the vector values here. Save a little time here. I'm going to copy that. So v.size. So basically what our popback method does is it pops the last element out of the vector. So in here, let's just say v.popback. And let's go ahead and copy it a few times. And see what happens when we run it. Oh, had an issue here. Okay, sorry about that, guys. What I did was I forgot to change this back to pushback. So it was accessing, out of the range of our vector. So anyways, what's going to happen here is it's going to push 6 elements onto our vector, and then we're going to pop 4 elements off. So then when it prints out here, it should only have 2 elements left. So let's run it. And as you can see, it did just that. It added 6 elements for this loop, and then we popped 4 of them off of our vector. So now we're left with 2. So that's what the popback does. Pretty much the reverse of pushback. So that's pretty much all I'm going to cover in this video. In the next video, I think we're probably going to start in on some iterators. Since we now know about vectors, it would only make sense to cover a little bit about iterators before we get into things like lists and decks and queues and things like that. So if you like this video, please let me know by hitting the like button. If you've seen a few of my videos, you can go ahead and subscribe so you can see when I post new ones. And I would like to thank you guys for watching, and I will see you in the next video.